A killer is lurking in space. A giant black hole. A cosmic predator so powerful, it swallows light, bends reality, and shreds anything that gets too close. But what if one wasn't light years away, hidden in some distant galaxy? What if it appeared right here in our solar system? How long would we have before everything, even time itself, was gone? On today's episode of the Infographic Show, we're revealing what would happen if a black hole appeared in our solar system. -33 minutes, 20 seconds. It's February 2034. For the first time in decades, there is a great planetary alignment. All 7 planets in the solar system are aligned. Astronomers and the casual observer point their telescopes to the sky in anticipation of this once-in-a-lifetime event. But the solar system is about to get much more than it bargained for. Out in the darkness, an object unlike anything humanity has ever encountered closes in. A black hole moving at a staggering 155 million miles per hour, about 1/4 the speed of light. Somehow it's picked up speed, perhaps flung across space by a supermassive black hole or driven by some dark force humanity has yet to uncover. At this speed, space itself bends in its wake. Its event horizon is only a few hundred miles wide, smaller than the Earth's diameter, but its gravitational influence stretches across billions and billions of miles. Right now, it's about 93 million miles, or 1 astronomical unit, away from the outer edge of our solar system. In a matter of minutes, it will reach the Oort cloud, the vast icy shell of comets and asteroids that surrounds our solar system. Its gravity will disturb the Oort cloud's fragile orbits, hurling millions of comets and asteroids off course. Some will be flung into deep space, others will be thrown toward the inner solar system, including Earth. For now, the black hole is undetectable except for the subtle warping of light from distant stars, but every second it draws closer. 0 hour. The black hole tears into the solar system and immediately crosses Pluto's orbit in an instant. Pluto's long, sad history, once a planet then a dwarf, ends here, devoured by the cosmic monster. Astronomers know that even a stellar mass black hole, passing within a few dozen astronomical units, could disrupt planetary orbits. And in this case, the intruder's proximity is far more dangerous. Pluto's orbital axis begins to tilt under the combined influence of the Sun and the black hole. Its once stable 248-year orbit starts to stretch and warp, as if space itself were being tugged in 2 directions. Pluto is pulled closer and closer to the event horizon. The first thing to happen is tidal disruption. The side of Pluto facing the black hole feels a gravitational pull much stronger than the far side. The difference in force would be so extreme that it would begin to stretch the dwarf planet apart. For a black hole of this mass, that could begin well before Pluto even reaches the event horizon, the point of no return. As Pluto spirals inward, its icy crust cracks and boils as gravitational compression and internal friction generate temperatures of thousands of degrees Kelvin. Pluto, once a frozen world of nitrogen, ice, methane, and rock, meets a horrific end. It's spaghettified, stretched into a glowing ribbon of debris that spirals into the black hole's blazing accretion disk. The immense friction in this disk heats the remnants to millions of degrees, releasing bursts of X-rays and gamma radiation, a cosmic flare marking Pluto's violent end. Over the course of mere minutes, the dwarf planet is reduced to a thin ribbon of incandescent plasma, swirling around a hole in space-time. Some fragments are flung outward at a significant fraction of light speed. The rest vanish forever beyond the event horizon. To a distant observer, the light from Pluto's destruction flickers and fades until nothing remains but darkness. As the black hole continues on, a subtle but undeniable wobble begins to spread through the outer solar system. The outermost planets' axes shift, their orbital planes tilt, and their orbits around the Sun are thrown off. The black hole doesn't have to collide with anything to cause chaos. Its mere presence has already begun to destabilize the solar system's fragile harmony. And this is only the beginning. Hour 8. The black hole has now traveled 1.4 billion miles, and now Neptune is in its path. The planet is a gas giant composed mostly of hydrogen, helium, and methane. The black hole's gravitational well starts to strip the planet's outer layers. Billowing clouds of gas are drawn outward, pulled into thin tendrils that spiral toward the dark center. To observers from Earth, Neptune's transformation would be surreal. As it moves away from us, its familiar blue hues shift into deep crimson. The effect is known as a redshift, as the wavelengths of light stretch under the immense pull of gravity. Then, as the planet passes behind the black hole, light from Neptune bends around the dark sphere, creating an eerie gravitational lens. The gas giant seems to flatten and smear across the black void, as if reality itself is bending. When it swings back toward us, its light turns blue-shifted due to the wavelengths bunching up as the planet appears to surge forward. The closer Neptune drifts toward the event horizon, the more violently it's torn apart. The planet's 14 known moons, including Triton, are ripped from orbit. Some are flung into interstellar space, while others are captured by the black hole's gravity. Within hours, Neptune's atmosphere collapses inward, heated by compression and tidal stress to tens of thousands of degrees Kelvin. The rest of the outer solar system is not spared. With Neptune gone, the delicate gravitational balance that holds Uranus, Saturn, and Jupiter in place begins to shift slightly. Their orbits begin to distort. Even if Earth isn't directly affected, at least not yet, the architecture of the solar system has been permanently rewritten. The black hole continues its unstoppable advance. Hour 14. The black hole has now traveled to Uranus, covering 994 million miles in hours. For billions of years, the pale blue giant has drifted serenely through space. But as the black hole closes in, Uranus begins to deform under the immense gravity of the black hole. The black hole's tidal forces reach deep into the planet's interior, stirring its icy mantle and superheated core. Shockwaves ripple through its structure as layers of gas are stripped away in great ribbons. Soon Uranus's once smooth atmosphere becomes chaotic. Massive storms thousands of miles wide form as gravity tears the planet apart from the inside out. Within moments, the black hole's gravity dominates completely. To astronomers on Earth, the scene is both horrifying and hypnotic. Light from Uranus's destruction outlines the black hole's event horizon in negative relief, much like the sun's corona during a total solar eclipse. At this point, the gravitational consequences of losing two gas giants and Pluto would reach even the Earth, and the Earth's orbit begins to wobble. The consequences of that are devastating. Even a slight alteration in Earth's orbit could change our distance from the Sun, plunging the planet into a new ice age or raising global temperatures to extinction levels. Seasons would warp, climate systems would break, and life would begin to die off in waves. Fortunately, Earth won't be around long enough to see this happen. As the black hole moves past Uranus, the background stars also begin to bend and stretch like reflections in a warped mirror. Every telescope on Earth locks onto the distortion, trying to study what is essentially the solar system's slow destruction. Uranus is gone, consumed in light and gravity. The black hole keeps moving inward. Hour 26. The black hole reaches Saturn. Its rings have circled the planet in a perfect balance of ice, dust, and rock. Until now. As the black hole draws near, Saturn begins to tremble. The gravitational gradient between the near and far sides of the planet becomes enormous. The black hole's pull starts to distort Saturn's shape, stretching it slightly along the direction of the gravitational field. Its atmosphere, composed primarily of hydrogen and helium, begins to churn violently. Storms the size of continents rip across the cloud tops. Then the real destruction begins. Saturn's rings, spanning almost 174,000 miles in diameter, but only about 33 feet thick, are the first to go. The icy particles that form the rings are only loosely bound by gravity. As the black hole's gravitational pull grows stronger, these particles are pulled from orbit. The rings unravel, forming long, ghostly arcs that spiral toward the black hole. From afar, they look like strands of silver string being wound around a spool. Meanwhile, the black hole's influence disrupts the orbits of Saturn's 145 known moons, including Titan, the second largest moon in the solar system. Titan's thick nitrogen-rich atmosphere begins to erode as the moon's orbit decays. Smaller moons are stripped away completely, some captured by the black hole, others thrown toward Jupiter's realm at incredible speeds. As Saturn succumbs, the rest of the solar system feels the shift. The black hole's gravity now begins to challenge the sun's. Jupiter's orbit starts to drift, and the asteroid belt experiences violent perturbations, sending countless fragments tumbling toward other planets. For a brief, haunting moment, Saturn's atmosphere glows as its outer layers are drawn away, forming a spiral of luminous gas before being consumed. To the telescopes on Earth, the black hole's lensing makes Saturn appear to stretch and fade, a planet being erased in real time. Hour 28. After traveling another 400 million miles, the moment arrives when the solar system's largest planet meets a much bigger giant. Jupiter has twice the mass of all the other planets combined. For billions of years, it has acted as our cosmic shield, deflecting comets and asteroids away from the inner planets. But against a solar mass black hole, even Jupiter's immense gravity is nothing. At first, the black hole's pull subtly distorts the planet's magnetic field, which is around 20,000 times stronger than the Earth's. The magnetic lines twist and collapse as the black hole's gravitational field starts to overpower them. Soon after, Jupiter's dense atmosphere begins to compress and bulge. Massive storm systems, including the Great Red Spot, start to elongate and fragment under the stress. Unlike Uranus or Neptune, Jupiter is a gas giant of unmatched scale, with a radius of about 43,500 miles and a core that may be composed of metallic hydrogen, a phase of matter only created under extreme pressure. As the black hole appears, Jupiter's internal pressure skyrockets, the outer atmosphere flattens on one side and stretches on the other, creating shock waves that ripple through the planet's fluid layers. Temperatures soar and the gas begins to ionize, glowing in bands of red and violet. The planet starts to unravel from the top down. Hydrogen and helium escape into space, drawn into long luminous streams that circle around the black hole. The remaining mass of Jupiter collapses inward, igniting like a failed star. For a brief moment, it shines in a last dying flash of brightness before it's shredded completely and pulled into the black hole's event horizon. The destruction of Jupiter marks a turning point. For the first time, the black hole's gravitational dominance extends all the way to the inner solar system. The asteroid belt, once held in check by Jupiter's massive gravity, destabilizes even further. Now, the Sun's reign over its planets is no longer absolute. As the black hole passes within Jupiter's orbit, Earth begins to feel its tidal pull. Our planet's orbit starts to warp even more as we drift ever so slowly toward the black hole's gravity well. Jupiter is gone, the black hole continues inward, and for now, for the first time, the inner planets stand exposed. Hour 30. The path the black hole takes is an especially dangerous one for the remainder of our solar system. The outer planets are gone or scattered, and now the solar system's rocky worlds are in the line of fire. But Mars is no gas giant. It is a small, dusty planet, only 1/10 the mass of the Earth, and with an atmosphere just 1% as thick. That thin veil of air won't offer much resistance to a force that can bend light itself. The red planet's faint pink skies turn deep crimson as gravitational forces start to rip at its surface unevenly. The black hole's gravitational pull causes massive dust storms. They rage with apocalyptic fury, their winds accelerated by sudden pressure gradients that have never existed on the planet before. Mars's two tiny moons, Phobos and Deimos, don't stand a chance. The black hole's gravity tears them into fragments that rain down on Mars in a fiery bombardment. Within hours, the thin atmosphere is stripped away completely, and much of the planet's surface dust is sucked into the black hole. Asteroids, some as small as pebbles, others hundreds of miles wide, are launched in every direction from the destabilized asteroid belt between Mars and Jupiter. The largest, like Ceres, Vesta, and Pallas, are ripped from their orbits and sent careening through the inner solar system. Smaller meteors rain down on the Earth, suddenly filling the night sky with shooting stars. As Mars is consumed, the solar system begins to lose its shape and its gravitational center shifts. Planets no longer orbit neatly. Instead, they begin to drift towards the black hole. And now, as the black hole crosses the gap between Mars and Earth, the countdown truly begins. Our world, the one we call home, has entered its last chapter. Hour 30 and 21 minutes. The black hole looms closer to Earth, filling the sky. A black void ringed by a blazing halo of light, the accretion disk, formed from the shattered remains of planets, moons, and asteroids, devoured along its path. The presence bends the stars into eerie arcs and smears the familiar constellations in the night sky. Earth is now under the influence of an object whose gravitational pull is 100 times stronger than the Sun's. Every satellite, every moon, every human-made machine orbiting our planet begins to drift toward it. The International Space Station, traveling at over 17,000 miles per hour, is pulled away from Earth's orbit. The astronauts inside watch helplessly as their home becomes further and further away. The moon begins to tremble in its orbit. Normally, it circles the Earth at a distance of 238,000 miles, stabilizing our tides and axial tilt. But the black hole's gravitational force is far stronger than anything the Earth-Moon system has ever endured. The moon's orbit elongates, stretching into an unstable ellipse. And then, in a violent gravitational tug-of-war, it is completely ripped away from the Earth. For a brief moment, the moon becomes a captured satellite of the black hole. Its surface fractures as competing tidal forces tear it apart. Then the black hole consumes it. Back on the Earth, the effects are apocalyptic. The planet's crust groans as gravitational stress causes unprecedented earthquakes. Tsunamis hundreds of feet tall race across the oceans, as tides surge uncontrollably. The atmosphere begins to distort. High-altitude winds whip around the planet at thousands of miles an hour, stripping away the ozone layer and spreading superheated air. If humanity has somehow survived this long, civilization's last moments unfold under a sky that defies logic. The sun is no longer where it should be. Instead, its light bends around the black hole, creating twin mirages. Day and night lose meaning as light warps unpredictably. Humanity begins to witness impossible horrors, such as buildings stretching toward the sky, time slowing down right in front of them, the absolute darkness of the singularity, where not even light can escape. In essence, the laws of physics themselves seem to come apart. Soon the atmosphere begins to peel away, drawn toward the black hole's gravity well. The upper layers ionize, glowing faintly as they spiral outward. The planet's oceans follow, drawn upward into space like a reverse waterfall, leaving behind barren, molten rock. For a brief moment, time stops. Then, as the planet crosses the event horizon, all light vanishes. Earth, once a pale blue dot teeming with life, is gone. Hour 30 and 30 minutes. The black hole is now entering the heart of the solar system as it travels toward Venus. The second planet from the Sun has always been extreme. Its atmosphere is about 93 times denser than Earth's. It's composed mostly of carbon dioxide, with clouds of sulfuric acid swirling high above the surface. Surface temperatures reach 462 degrees Celsius, which is hot enough to melt lead. As the black hole enters the neighborhood, Venus's thick atmosphere becomes both its armor and its doom. Gravity begins pulling the upper atmosphere first, stretching it into a glowing funnel that spirals toward the black hole. The pressure difference between the near and far sides of the planet increases exponentially, creating supersonic winds. Within hours, the clouds of sulfuric acid are stripped away, forming a brilliant ghostly trail of ionized gas around the black hole. Venus's slow rotation of just once every 243 Earth days now works against it. The black hole's gravitational force creates violent tidal stress between its day and night sides. The crust buckles, releasing long-buried volcanic gases. For a fleeting moment, Venus glows as molten rivers erupt across its surface. And then, as the black hole moves closer, that molten surface is pulled upward, stretching like taffy under unimaginable strain. Meanwhile, Mercury's orbit begins to wobble as it feels the tug of both the Sun and the black hole. The Sun itself trembles slightly. Its outer layers distort as the immense gravitational force, 100 times greater than its own, begins to pull at it. The gravitational center of the solar system has now shifted completely. Everything that once orbited the Sun is now subtly spiraling toward the black hole instead. For a few hours more, Venus resists. Its molten surface clings together, its atmosphere torn into fiery ribbons that stretch for millions of kilometers. And then, with one final pull, the planet collapses inward, disappearing into the black hole's event horizon. Hour 30 and 41 minutes. After traveling 31 million miles, the black hole approaches the last planet left in our solar system, Mercury. The tiny airless world is just over 3,000 miles wide. It orbits the Sun faster than any other planet, with a revolution taking only 88 days. Mercury has no atmosphere, no water, and no moons. It's a world of rock and metal made up mostly of iron, as its core makes up about 70% of its total mass. When the black hole reaches Mercury, its surface is friction heated by tidal stress to temperatures hotter than 1,000 degrees Celsius. The iron core liquefies. The planet begins to disintegrate. Massive plumes of metallic vapor rise from its surface, pulled into the black hole's gravitational well. For the first time since the solar system's creation, the Sun no longer has anything orbiting it. Hour 31. There are no planets left. The only thing the black hole has yet to devour is the Sun. It finishes the journey of 37 million miles from Mercury to the star at the heart of what was once our solar system. The Sun is enormous, at about 870,000 miles across, and has a mass of approximately 330,000 times that of Earth. Yet compared to a black hole 100 times the Sun's own mass, it is practically nothing. As the black hole approaches within a few million miles, its gravitational influence begins siphoning off the Sun's plasma layers. At first, the Sun brightens. Its outer atmosphere, the corona, stretches and distorts as the black hole's gravity begins pulling material from it. Streams of incandescent hydrogen and helium arc outward, forming vast bridges of plasma that are sucked into the black hole's accretion disk. Temperatures in the accretion disk soar above 100 million degrees Kelvin, making it thousands of times hotter than the Sun's core. Within hours, the Sun's mass begins to drain rapidly. The black hole devours it at an accelerating pace, feeding on its plasma like a cosmic predator. The inner layers collapse, and the sun's magnetic field twists violently, releasing solar flares and coronal mass ejections that shoot off in every direction. Each of these eruptions releases the energy of billions of hydrogen bombs. But nothing can stop the inevitable. The more mass the black hole consumes, the stronger its pull becomes. Soon the entire star deforms into a glowing spiral of plasma. The last remnants of the sun are compressed and stretched into an incandescent ring around the black hole's event horizon. The black hole, now slightly more massive and surrounded by the faint afterglow of its meal, continues its journey through space. If any distant observers were watching from light years away, they would see the sun's final moments as a bright flash in space that lasts only hours after fading completely. Then, there would be nothing but darkness. Just over 30 hours after the black hole entered our solar system, it consumed everything in it. A black hole appearing in our solar system would spell disaster. But what about its mysterious opposite? Watch What is a White Hole, Opposite of Black Hole, to explore one of the strangest ideas in the universe. Or click on this video instead.